Program here is going to involve the creation of a very famous mathematical sequence of numbers called the Fibonacci sequence. The Fibonacci sequence is commonly used in explaining the rates of growth. It shows up a bunch in nature. It's quite famous. So here's how it works. The Fibonacci sequence starts with these two values, 0 and 1. These are the first two numbers of the sequence. Then the rule for each number that follows that second number, which is 1, is each number is the sum of the previous two. So in this example, the sequence would start with 0 and 1, and then the number that would follow it would be 0 plus 1, which would be 1. The number that follows that one is 1 plus 1, which is 2. The number which follows this is 1 plus 2, which is 3. The number that follows is 2 plus 3, which is 5. The number that follows is 3 plus 5, which is 8, and then 13, and then 21, and then 34, and then so on and so on and so on. The numbers do get quite large very quickly. So what we want to do is we want to create a program that will display these numbers, because imagine that you were doing a real life example, and then for some reason you needed to access the 100th number of the Fibonacci sequence. So you can't use a formula to figure out what it is. This is just a perfect example of a loop. So you're not going to, take your calculator out and start adding numbers together 100 times until you get it. You would write a quick computer program, which is much faster than adding numbers together 100 times. And then it's going to look something like this. So what we're going to do is we're going to start with two numbers, n1 and n2. These are going to be 0 and 1 initially, and then we're going to generate a third number. So the third number is going to be n3. And then we'll carry on from here. So let's set our initial value. So n1 is going to be 0, and then n2 is going to be 1. And then we'll start our sequence from here. So in order to display the full thing, we need to display these two values here. So let's see out n1 with followed by a space. I'm going to display them all on one line instead of vertically. It'll just look a little cleaner. See out n2. We'll put a space here as well. And then we'll start our loop. We've displayed the numbers 0 and 1. I can run it just to show you what we've got so far. I've got 0 and 1, and then all of the numbers are going to be arranged on this one line. So what I want to do is I want to get the first 10 numbers. So what I want to do is I want to write an appropriate for loop for this. I'll move this up so it's easier for you to see. But what I want to do is I want to think of the logic of what I'm doing as I'm considering the way that I write this for loop. So the one change that I want to consider is now I want the first 10 numbers. I've already displayed the first two numbers. So I could have this go from 1 to 8 because I know that I will have 8 more numbers to display. However, the logic that I want to do is the next number that I will be displaying is the third number. So I'm going to start my counter at 3 instead of 1, because I know that the next thing that the loop is doing is going to be kind of like the third step of the process. So I'm going to honor that by putting 3. And I'll show you the reason why I do that is imagine that I for this program, we're going to display the first 10. However, if I needed to change the program and display the first 15 or so, I would put that value here. So I'm going to put while I is less than or equal to 10. So if I reduced it by 2 and left this at 8 and went from 1 to 8, then any new value that I would want to put in, I would have to remember, oh yeah, reduce by 2 because I've already displayed 2 of the values. So I'm going to go from 3 to 10. You go I++. I'm ready to go. Okay, so the new number N3 is going to be equal to the sum of the previous two. So the previous two number in this example are N2 and N1. I will space those out. So I've got N2 and N1 are going to form the results for N3. And then I want to display it. N3, I'm going to do it in the same fashion as the earlier two. I just realized I put N2 here. Let's put N3 there instead. So we're going to then display N3. Now what I have to do is I have to prepare all of the values so that I can get the following number in the sequence. So what I have to do is I essentially have to shuffle all of the numbers down. So if we look at the example at the top, imagine that I just got the number 5 by adding together 3 and 2. But now when I'm getting 8, I need to essentially discard the 2 I don't care about anymore. And then I'm going to be looking at the 3 and the 5 instead. So here's how this is going to work. The first thing that we need to do is N1 is going to get the value of N2. So we're going to pull it down one level, and then we're going to have N2 is going to get the value of N3, and then our program is ready to go. So every time you go through the loop, it's going to shuffle these down. Now, if you don't understand what the loop is doing, please pause the video and trace the variables through the loop. Anytime you encounter a loop that you don't understand, you should be tracing the variables. So do a little walkthrough of the loop, and that is the only way to familiarize yourself with what the loop is doing if you can't immediately see what the loop is doing. So let's take a look at what happens when we run this. So we're going to get the first 10 values, and there we go. We go all the way up to 34. Now, again, this is why I did this. I didn't go 1 to 8. I went 3 to 10 because I have 10 values here. And if I wanted to take a look at value 15 all the way up to 15, I can run that again. And then I get all the way up to value 15. Now, what would happen in the alternate scenario where instead of taking a look at the first 15 numbers, what we wanted to do was we wanted to go until we get a particular number reached. So imagine I wanted to go to the number 1000. And that's what we're going to write next. So we're going to redo this loop on the next line. So we're going to do an end L here. You know what? Let's put 2 of them just so we get a little bit of spacing between this. We're going to reinitialize our N1 is going to be 0. And then N2 is going to be 1. So we're going to reinitialize those 2 values. N3 we don't really care about because we're going to be recalculating it the first time we go through the loop. Now, I want to go to the number 1000, which I feel like I could estimate by looking at this sequence roughly how many more times it would take to get to 1000, but computers are terrible with estimating values by looking at a set. we'd have to put a bunch of extra programming in that would get it to do that. So in this scenario, we do not know how many numbers from the sequence it will take to get to the number 1000. So we're going to find out. So here's how it's going to work. Let's do a while loop. And we're going to keep going while n3 is less than or equal to 1000. So we're going to go up to that value. And then the content of the loop is the same. So if you want to save yourself some time, you can copy and paste that down there. And then here we've got another loop that goes up to the value 1000. So let's run the program. And then we're going to see both scenarios. There we go. So what I did was I wanted it to go all the way up to something that would be at least 1000 and then stop. Now, if we take a look at this, oh my gosh, I didn't display items 1 and 2. So we should put in these 2 lines. I will add that to my sequence. There we go. So I'll run that again. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We've got 18 values here. Now, it would have been really difficult to figure that out. And imagine we were looking for, say, a number that was 1 million. You know, keep going until you get a number that's over 1 million. How many numbers would we need? We have no idea. So this is why it's a really good idea to have a while loop for this kind of scenario.